So in our last discussion on acids and bases, we're going to look at this very important molecule, CO2. So CO2, you hear a lot about it. It's in the news because it's a greenhouse gas. But it has some very unique chemical properties that are different from a lot of the other molecules that are on the that we know about. So this molecule, it turns out, carbon dioxide, right, is a gas, and when it dissolves in water, it can form this acid, H2CO3 aqueous. And so this acid is known as carbonic acid. So this is why if you bubble carbon dioxide in soft drinks, the fizzy stuff is carbon dioxide bubbles, that they actually make the soft drink a little bit acidic because the carbon dioxide dissolved in the aqueous medium forms this carbonic acid. So many soft drinks also have other acids added, like phosphoric acid and so forth, to make the taste a little more sour, a little more tart. But this carbonic acid is a good acid. So carbon dioxide dissolves in water to form this acid. So this is relevant in talking about global warming and greenhouse gases because carbon dioxide, because it reacts in this way with water, water is actually a very good sink for carbon dioxide. So carbon dioxide reacts with water in our oceans, and our oceans can store carbonic acid. But this causes other problems because it increases the acidity of the oceans. And that makes it hard for certain animals that need to make shells and so forth to make their shells because of the high acidity. And we're going to talk about that in just a second. So carbonic acid. Now it turns out that carbonic acid is unstable. So I've drawn these double-headed arrows to indicate that in fact mostly carbonic acid will dissociate into this stuff. So carbon dioxide only reacts a little bit with water to make carbonic acid. And in fact, as the temperatures go up, as the temperatures of oceans and so forth go up, or any water medium, the carbonic acid will break apart more into this gas. So if you want to keep your sodas from going flat, it's best to keep them refrigerated because at higher temperatures this reaction is going to go even more to this direction, and you're going to break down that carbonic acid into this gas, and the gas gets released, and then your sodas are no longer fizzy. In the oceans, of course, if we've got carbonic acid from the dissolved CO2, then the more CO2 we have, the more carbonic acid we have. But the warmer the oceans get because of global warming, the more this carbonic acid is going to break down and release that CO2 back into the atmosphere. Now, carbonic acid is an acid like other acids, but it is a weak acid. It's not on our list of the strong 7. And so what happens with carbonic acid is it can react with water, donate a proton, Bronsted-Lowry way. Oops, that's going to be an H2O. Yeah. But it's weak. And what we get is this species, HCO3 minus, that's known as hydrogen carbonate, and H3O plus. Why did I write that? H3O plus. So there's our hydronium species, our acid species. So this is how carbonic acid can dissociate a little bit to give us these H plus ions, these hydronium ions. And then we've made hydrogen carbonate. Now this is also known as bicarbonate. That's the older name for this. And you might be familiar with sodium bicarbonate. That's one of the chemical names now. We would really call that sodium hydrogen carbonate. But that's one of the older names for the active ingredient in baking soda. Baking soda is mostly sodium hydrogen carbonate. And sodium hydrogen carbonate, if you've ever reacted baking soda with vinegar, you know it is a base. So sodium hydrogen carbonate, HCO3 minus, can act like a base. So if you take something that's acidic like HCl and you add it to something that has bicarbonate in it, then this will react by giving its proton to the base, will make carbonic acid, H2CO3, in this form, so we'll make that molecule plus chloride. Now this is a weak acid, so it tends not to redissociate this way, right? Because not very much of that happens, right? It's weak. And in fact, if you're at a fairly warm temperature, you're going to see that these bubbles form, CO2. So if you ever made those volcanoes as a kid in a science fair project, this is what's going on. Your acid reacts with the bicarbonate, makes carbonic acid, which then decomposes to give you carbon dioxide and water. That's just the reverse of this reaction. And then the fizzy bubbles come out as the carbon dioxide gas. Now what's also interesting about carbon dioxide is that if you were to give up another proton, so this hydrogen carbonate, bicarbonate, could give off another proton, give up another proton to, let's say, a base, to make this species carbonate, CO3 2 minus, and there's the other H plus that has come off, right? So we've made carbonate now. Carbonate, it turns out, is also a good base, but it's what we would call a diprotic base. So it would need to react with 2 moles of HCl to make H2CO3, which would then decompose into carbon dioxide gas and water, and 2 chloride ions, 2 moles of chloride ions. This is also how, by dissolving carbon dioxide into water, you can react this with certain bases that are around, and you can hook this carbonate up with certain kinds of metal cations. So we can make like magnesium carbonate, MgCO3, or calcium carbonate, CaCO3. And this happens all the time in geology. So a lot of carbon that's on our planet gets bound up into rocks, into limestone and dolomite and these kind of minerals. And so these carbonate species then get held in those forms as calcium carbonate. Calcium carbonate is also the material that makes up the shells of lots of marine creatures, mollusks, and so forth. Now, certain kinds of marine creatures also have chitinous exoskeletal shells, but many creatures like sea urchins and most kind of mollusks have calcium carbonate shells, and they get that calcium carbonate from some of the carbon dioxide and carbonate and so forth that's already in the ocean, so they're able to form that by mineralizing that material. So that's just a little bit of the interesting chemistry that's going on involving acids and bases.